Hello everyone, I'm Alessandro Canossa, Associate Professor at the Royal Danish Academy. I'm here to present our work on detecting toxic behavior through gameplay. This work was only possible through a collaboration with my colleagues from Ubisoft, Dimitri Salimov and Amanda Zadvar, my colleague from Northeastern University, Kasper Artveld, and Yorgos Yanakakis from the University of Malta. The type of behavior we're here to identify, it's represented by these snippets of chats between players. Sometimes most of the time they are extremely unpleasant, but sometimes in some small rare cases they just become extremely hilarious, like when players call each other, you have the map awareness of Christopher Columbus. Now, many researchers have been looking at this phenomenon, and there's been a lot of different labels or ways to call it. One thing they all agree is that it's a behavior that intentionally disturbs other players' experience and well-being. Our effort in this paper and this research was to establish a framework for prediction of toxic behavior in online games. We went through 3 steps: appropriately sampling the players for comparison, that was the first one, comparing multiple methods for selecting the features, and using machine learning, namely random forest, with the purpose of predicting the toxicity of players based on their behavior. Now, our hypothesis, the first, is that toxic players are distinguishable just by looking at their behavior in the game from non-toxic players. The second hypothesis is that it's possible to distinguish between different levels of severity of toxicity. And the third hypothesis is that we can actually distinguish between different types of toxic behavior. The game that we used was For Honor, a brawler released by Ubisoft in 2017. We were able to actually work with the data provided by the community managers of the game, and we are able to identify a sanction matrix that the community manager used. The sanction matrix labels toxic players according to 2 orthogonal parameters: whether they display offensive behaviors like obscene, racist, or of hateful behavior, or whether they display an unfair advantage, trying to cheat or exploit the game for own advantage. These 2 types of behavior, they can be cause for a warning when it's a small first offense, or a ban when it's repeated a serious offenses. As I said, the first step was to sample the population. We had 20 million players. For most of these players, we have only a partial tracking where only a few of the gameplay variables are tracked. So we wanted to look for an overlap between 2 sets. We wanted to look for players with extensive tracking and that they had been sanctioned, either with a warning or with a ban. That reduced a lot the data set that we had available. At this point, this small data set was split in 4. We have players with offensive behavior that received a warning, offensive behavior that receive a ban, unfair advantage that receive a warning, and unfair advantage that receive a ban. First, we extracted 36 features in total. The full list is present in the appendix of the paper, and they were split in 5 different categories. Activity modes is how players engage with the game, disengagement and inactivity, movement modifiers, how well players do in the matches, and the chat actions they perform. The selection process we used to identify the features that mostly are appropriate for our work was a hybrid. We contacted a team of domain experts from the developer side and asked them to identify which features would be more likely to be correlated with toxicity. At the same time, we also ran a statistical data analysis comparing the frequency distribution for all the features for sanctioned and unsanctioned players, and identified 9 additional features. These are the 13 features. The 4 selected by the experts are flagged with a little star, and the 9 that we identified statistically are the rest. The first hypothesis we had is that it is possible to differentiate between players that have displayed any form of toxic behavior and players that did not. We ran this analysis on the small dataset for whom we have 100% of the features tracked, and we are able to correctly identify sanctioned players with 77% of the time, unsanctioned players 87% of the time, and averagely 82% of the time. Now, we wanted to try to run this analysis on a larger dataset, so we actually looked at players for whom we have 50% of the features tracked. The performance went up considerably because we were able to identify correctly sanctioned player 85% of the time and unsanctioned player 91% of the time. The average accuracy of this two-class random forest model is 90.7%. The second hypothesis looked at differentiating between unsanctioned players, players that received a warn and players that received a ban. In the first case, the correctness is 86%, 67 and 48. The averagely is 85%. The third hypothesis was to differentiate between players that have never been sanctioned versus players that have been sanctioned for being offensive or players that have been sanctioned for seeking an unfair advantage. And again, the accuracy is pretty high with 88%, 86 and 76, averagely 87. So our hypotheses have all been verified. In conclusion, this framework shows that it's possible to facilitate community management, making them not rely solely on peer reporting. At the same time, it requires a good label dataset because the quality of the label dataset defines the type of accuracy that we can get. And lastly, we always recommend not to automatize this process and always have humans in the loop because we're definitely trying to avoid a pre-crime scenario. I would like to thank you all very much and thank my collaborators from Malta University and Northeastern University as well as Ubisoft.